Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about how to find next greater element in an array. Okay, just see here. They will give a value n in which they will give how many size of the array. Then see here, and then they will give an array 1, 3, 2, 4. Okay. Now we want to return the next greater element of each and every element. Okay. See here. For this one, what is the next greater element? It is 3, right? Because after 1, that is 3, right? So it is the greater element immediate next to 1, right? After this one, 3 is immediate next. Okay. So 3 is the output here. Then for 3, whether this 2 is greater, no. Whether this 4 is greater, yes. Yes. So 4 is the answer. Now for this 2, 4 is the next value. So 4 will be the answer. And then for this 4, there is no value on the right side, right? On the right side, there is no value. So the value is what? -1. So the output is what? -1. Now this just come here. Value is 5, and then the array size is 5. Now 6. What is the next greater element of 6? It is 8, right? So print 8. Sorry. Make the first element's next greater element as 8. Okay. Now again for 8, what is the next greater element? Whether 0, no. Whether 1, no. Whether 3, no. So -1 will be the answer. Right? Again for 0. For 0, 1 is greater, right? So 1 will be the answer. And then for 1, 3 will be the answer because 3 is greater, next greater, right? So 3 will be the answer. Then for 3, there is no elements right side. So -1 will be the answer. Clear? Fine. Now, how to approach this problem? Simple. As of now, I told you, right? Same logic. Just apply. Let's see here. If the array is 1, 3, 2, 4, just take this one and check whether any greater element towards the right side. Towards the right side. If there exists any greater element, just return it. See here. First of all, I'm checking with 3. Yes, it is greater, right? So 3 will be my first answer, right? Again, I'm checking for this 3. Whether 2 is greater, no. Whether 4 is greater, yes. Yes. So I will take this 4. Now again, I am checking this 2. And then for this 2, whether 4 is greater, yes. So put this 4. Again, for this 4, there is no right side value, right? There is no right side value. So just keep -1. Finish. So this is the first approach. So first approach is this. And then what is the time complexity and space complexity? I can say time complexity is O of n square because we are fixing one element. We are fixing one element and going throughout the array. So it is O of n square. And what is space? It is O of 1. Okay, fine. Can we optimize it? Can we optimize it? Okay. If just observe carefully, we want the next greater element, right? Next greater element. Why can't we go from this side to this side? So that I can check whether this element is greater than this element, like that. Okay. Okay. Fine. But here's some problem. Here's some problem. What is the problem? If, take for example, if this is the array, then we are taking this 4. Then going for this 2, we can say this 4 is greater. This 4 is greater. But if for this 3, how can we check whether this 4 is greater? So we want to store somewhere, right? We want to store somewhere. So just observe. We can take array and then we can take the stack so that we can store the elements one by one. Okay, just see here. See this approach carefully. It will be super cool. See here. First of all, I'm taking this 4. Whether my stack has anyone? No, no. So take the output as 1, -1, sorry, -1, and then put this 4 in the stack. Fine. This is the first step. Again, we are going with 2. 2. Whether stack contains any element? Yes. What's the element? It is 4. Whether 4 is greater than 2? Yes. It is greater. So it can be the next greater element, right? It can be the next, it should be the next greater element, right? So I will update this as 4 and then I will replace it as 2. Fine. Again, we are checking with 3. Is stack is empty? No. Stack contains values. Okay. 2 is greater than 3? No. No. So pop it out. Pop it out. No. 4 is greater than 3? Yes. Just put here and then just push 3 inside that stack. Now again, for this one, whether stack is empty? No. Whether this first value is greater than 1? Yes, it is greater than 1. So update it and then move on to the stack. Now we are going to this question and then now my loop is terminated. Now what's the output? 3, 4, 4, -1. See here? 3, 4, 4, -1. Understand? Let us again solve by using this example so that it will be more clear. Okay, 6, 8, 0, 1, 3. So 6, 8, 0, 1, 3. Fine. Now, just observe carefully. I have a stack, and then inside the stack, it is initially empty. Now for 3, whether the stack is empty, yes. So minus 1, minus 1. Now update 3 again for 1, whether stack is empty, no. Whether the stack top is greater than 1, yes, it is greater than 1. So put 3 here, yes. Again, push this 1 here. Fine. Again, for checking for 0, whether stack is empty, no. Whether top element is greater than 0, yes. So keep us the next greater element. Now add this 0 to the stack. Now again 8. Whether the first element is greater than the 8, no. Pop it. Again, no. Pop it. Again, no. Pop it. Fine. Now stack is empty. What should I do? I should update what? Minus 1. That's it, right? I should update minus 1 and then I will put 8 inside the stack, right? Right. Now again 6. Whether the stack is empty? No. What is the top of the stack? It is 8. 8 is greater than 6. So updates 8 and then insert 6. Fine. Again, go here. There is no elements. So stop. Stop. So this is my output. Yes, this is my output. So this is what the all about the logic and the approaches. Now let's see about the time complexity. What is the time complexity of this approach? Okay, let us observe carefully. Here I'm just traversing once the array. Here I'm traversing once the array. Okay. Again, inside the stack, how much elements I can store? I can say I can store almost n elements. I can store almost n elements. Almost n elements. Beyond this, we cannot move, right? Almost I can store n elements. Now, if I stored one element and popped it out, can I add it again? No, no. So that I can say it should be taken less than the n times. It should be taken less than n times. So I can say O of n plus n, maybe at the worst case n plus 1. This n is for traversing and this n is for this stack, right? So it's approximately equal to 2n and approximately equal to what? O of n. Fine. So this is what the time complexity. Now, what is space complexity? I can say space complexity is O of n. At the worst case, I will store all the elements here inside the stack. Just take for example, if I want to store all the elements, just take for example, it is 1, 2, 3, 4, 5. If this is the case, I want to store all the elements inside the stack, right? So at that time, the space complexity will be what? O of n. Fine. Now this is what the approach. Let us see the code now. Just see here. Now, this is the brute force approach. Just I am initializing minus 1 to n elements and storing it in the result variable. Then for I in range of n, then for j in range of I plus 1 to n. Because we are moving to the plus 1 elements to rightmost element, right? And then we are checking whether any element is greater than the ARR of I. If ARR of I is less than any element, okay, it means any element is greater than ARR of I, then I will update it in result of I, okay, and then I will break, right, because it is an immediate next greater element. Then I will return the result. But see here, if I submit it, yes, what we have got? We have got the time limit exceeded error, right? Right. So why we get a time limit exceeded error? Because it runs for n squared. Now it is an optimized solution. See here, I have stack here. Then result is equal to minus 1 into n. Then for I in range of len of array minus 1 minus 1 minus 1, because we are traversing from right to left, right to left. While stack, while we have stack, and then stack of minus 1 should be what? Less than or equal to ARR of I. That means if the stack top element is less than or equal to the current element, then we want to pop it out, right? We want to pop it out until a number is greater than the current element or the stack is empty. Up to that, we want to pop it out. That's why I am popping it out, right? Again, if there is stack, I want to update that stack top to my result, because it is the next greater element, right? And then we want to append that stack with the what? The current element, right? And then return result. That's it, right? Let us submit it. Yes, it submitted successfully, right? And then an important note in this problem is many of them leads to a mistake. Like, see here, they forgot to put this equal. What will we will face if we put this equal symbol? We don't put this equal symbol. Okay, just see here. If this is my array, okay, let us see. Take another array like 1 5 5 5 5. Okay, so this is my array. Okay, now I have a stack. Okay, now I have a stack. Then I will put this 5 here, right? Initially, and then I put the result as -1, right? My result is -1. Let me take another. Yes. Now I take this 5. Whether this 5, sorry, whether the stack is empty? No. Stack contains what? 5. 5 is what? Less than 5? No, no. So we don't pop it out. We don't pop it out, and then we will take this as a result. Okay. Then we will push this 5 here. Again, for this 5, we will check this 5, and then we will put here. Then 5 will be there, and then 5 will be there. But actually the answer should be what? 5 -1 -1 -1 -1. But what we have got? We have got 5 5 5 -1. Right? So this is wrong. So this is what the major mistake everyone does. Okay. So don't do this mistake. Just avoid this mistake. Just put here. That's it. Thank you.